All right, everybody, this is 2.4. We're talking about synthetic division. So last time we did long division. We're going to do a quick review of that so that you can compare which you prefer, okay? I'm going to, on your test, you are going to at least have an example where you're going to need to use synthetic division. So please make sure that you do go through this video and do your homework using synthetic division. Okay? All right, so here we got long division. Okay? We're dividing this polynomial, if I can use my pen, by x plus 2. Okay, and I already have that written out for you. If you need to pause and get caught up, that's fine. Okay, and then we're going to just start figuring out what we need to do. So what do we have to multiply x to give us x to the third? So that would be x squared. And so we multiply and then multiply. That would give us x to the third. And when we multiply this part, we would get 2x squared. And then just remember that we're always subtracting. So this would end up canceling. And then when we subtract 7, subtract 2, we'd get 5x squared. And then we repeat this process. We'll bring down the 15x, okay? And then we need to figure out what multiplies x to give you 5x squared. Well, that would be 5x. And then we multiply, so 5x squared. And then we multiply the 5x by 2, and that would give us 10x. And then again, we're subtracting. So we would end up getting 15 minus 10 would give us 5x. Bring down the 9. And what do we need to multiply x by to give you 5x? It would be 5. So we get 5x, and then 5 times 2 would give us 10. And again, we're subtracting, so we would end up getting -1. So we'd have a remainder of -1. And then we wrote down our problems, our answers, I guess I should say, as quotient. Again, the quotient is x squared plus 5x plus 5. Plus, we want to add the remainder over the divisor. So again, the remainder here is is a -1, and the divisor is x plus 2. Okay, so you've probably had practice doing long division, but here's a quick reminder. Okay, now here we're going to do synthetic division. As you see, this is the exact same problem. Okay, I'm going to kind of set this up, and it'll go a little slower this first try because I'm going to try and explain what's happening here. But then we'll do another example where we'll just kind of go through it. It goes a lot faster, okay? So the one thing you need to make sure you understand is when you are doing synthetic division, it needs to be a monic linear expression. The divisor is, I should say. So monic meaning a is 1, the leading coefficient would be 1. I guess it's not a, but like here this would be, the coefficient would be 1, here the coefficient would be 1. So those are monic, and then linear meaning that it is a degree of 1. So basically all of these have to have just an x. No exponent, no coefficient, okay? All right, so here we go. Let's give this a try. So first off, what you're going to want to do is we want to find the root that's associated with the divisor. So basically, like when we were to, if we had a problem like this, I don't know, something like x plus 2 and then x plus 5. When I say find the roots, like what makes this be 0? So our solutions for this example would be -2 and -5. So that's what we're trying to find first off, okay? So just an example. Okay, so for this one, we're going to write that down. For ours, it's -2. That's what would make this factor be equal to 0. Okay, we're going to drop or make a little L shape. It's kind of like a box, but only that part of the box. Okay, and then what we need to do is we need to list the coefficients. So this would be a coefficient of 1, so we'll write a 1. We have a 7, we have a 15, and we have a 9. Okay? After that, it goes really quick. So we're going to bring down the 1, and then we're going to take this, our 0, and multiply. And that would give us -2. And then we add, that would give us 5. And then we multiply -10. We add, we multiply, and we add. Okay? So those are the coefficients of our answer. Okay? So all we have to do is add in the variables and the exponents. Okay? So think about it like this. So we have, this is a degree of 3, and we're dividing it by a degree of 1. So again, when we talk about dividing polynomials, like if we had x to the 3rd over x to the 1, we would get x to the 2. So we should end up having a quadratic as our quotient. Okay, so we're going to bring this down. We're going to rewrite this. We'll have 1x squared plus 5x plus 5. And then the remainder is going to be -1 over the divisor, which is x plus 2. Okay? So basically, the thing about synthetic division is it simplifies it a lot. First off, you don't have to carry around all the variables, okay? You do need to make sure that if there is a missing term, just like before, you need to make sure you put a 0 for that, and we'll do an example of that coming up. Also, by finding the 0 instead of using like the +2, it changes it so that we're always adding. We always add each of these as we go along, which adding is a lot easier than subtracting, okay? So that's kind of some of the reasons why it goes a little faster, okay? And maybe that didn't go super fast, but let's do another example. So this one's about the same, has a cubic. We're dividing it by a monic linear factor, right? This part, okay? So we're going to go a little quicker for this one. So we're going to write down our 0, so that would be -1. Write down your factors, your coefficients. So we got 2, -3, 4, and -1. Okay, now watch it. We're just going to blink really fast. It's going to go really fast. Okay, so we drop it, we multiply. We add it, we multiply. We add it, we multiply, we add it. Okay? And let me just make sure I got this okay. It goes so fast. All right, this is a -10. Okay? And then we'll write down our answer. Again, it was a cubic divided by a linear. So we'll end up getting a quadratic. So 2x squared minus 5x plus 9 plus -10 over the divisor, which is x plus 1. And we're done. Okay, we'll try a couple more. Again, feel free to pause and give this a try. You're going to get it a lot better if you kind of pause and give it a try. Okay, so important, please make sure you add zeros for missing terms. So this would be x to the 4th plus 0x to the 3rd plus 0x squared minus 3x plus 5. And then we're going to divide that by x minus 2. Okay, so now we are ready to write down our 0, which would be 2. Write down your coefficients. So we'll have 1, 0, 0, -3, and 5. And then we're going to synthetically divide. Okay, so we'll bring down the 1, and then, again, multiply, add, multiply, add, multiply, add, multiply, add. Okay, so multiply, add, multiply, add, multiply, add, multiply, add. Okay, and then we just need to write down our answer. Again, this is a 4th degree divided by a 1st degree, so we should have a cubic when we're done. So we'll have x to the 3rd plus 2x squared plus 4x plus 5 with a remainder of 15 over x minus 2. Okay, so I don't know, I feel like it's very, really quick and it's easier. I think on your test, if you wanted to do everything, okay, not almost all of it, okay, I should say this back, try this again. Again, this only works well if you have a monic linear. So I think on our last example, we might have had, on our last lesson, if I can go back over there, okay, we went over a few examples. So like h here, that you could not synthetic divide, okay? That's not a linear term, that's a quadratic. Here, this is not monic, meaning the leading coefficient isn't 1. So we couldn't do synthetic division here or here for f, okay? So you'll still need to do long division if it's not a monic linear factor, okay? All right, so I have these two already done. If you ever want to maybe pause and give 4 and 5 a try. Just for the sake of the video, again, all of these are about the same. The steps are the same. So go for it if you'd like, okay? Let's do this one. So, like, this is atrocious. This is a 5th degree polynomial. And I'm going to show you how fast this is going to go. So we're going to write down our 0, which should be -1. Write down our coefficients. So 1, -1, 8, 2, -1, and -1. And then we're just going to bring down the leading coefficient, and then we're just going to multiply, add, multiply, add, multiply, add. So multiply would give us -1. Again, when I say multiply, we're multiplying those. Okay. Well, yeah. Okay, and we'll add, so -2. We're going to multiply, so that's a +2. We're going to add, multiply, add, multiply, add, multiply, add. Okay. And then we'll write down, again, it's a 5th degree, divide a 1st degree, so we should have a 4th degree when we're done. So we'll have x to the 4th minus 2x to the 3rd plus 10x squared minus 8x plus 7 plus the remainder. And we're done. So as long as you're okay multiplying and adding things, you're going to do great. Okay, so these last two, we need to talk about the remainder theorem and the factor theorem. Okay, we're going to learn this by doing these last two examples. Okay, so again, you could do synthetic division here because we're dividing it by monic linear factor. Okay, so again, our 0 would be 1, which is going to be really nice because we're just multiplying it by 1. Okay, and then our coefficients are 1, -1, -2, and 8. So we bring down the 1, and then we multiply, add, multiply, add, multiply, add. And we had a third divided by a first, so that will give us a quadratic, so x squared plus 0x minus 2 plus the remainder, which would be 6 over x minus 1. Again, if you have a zero term, just don't write it. So I'm going to rewrite that over here. So x squared minus 2 plus the remainder. Okay. So now I want you to evaluate your function when x is 1. So here we would have 1 cubed minus 1 squared minus 1, oops, sorry, I missed that one, minus 2 times 1 plus 8, okay? And you could do this on a calculator if you wanted to, but this is 1 minus 1, which is 0, and then we'll have minus 2 plus 8, so that should end up giving us 6. So what do you notice about our answer? It is the same as the remainder, okay? And this is the remainder theorem. It says when a polynomial f of x, so for this is our f of x, is divided by a linear factor, x minus a, so this would be our x minus a, the remainder is equal to f of a. So that's what we did here. So this is f of a. This is our x minus a. And this is just our f of x. Okay? So it's basically saying that if you evaluate the 0 of this factor, which is 1, if we plug 1 into the equation, it will give you the remainder. Okay? So if you're ever asked to find the remainder, you could do synthetic division, or you could just evaluate it at its 0. Okay? All right, let's try this next one. Okay, so again, we could use synthetic division. Our 0 is going to be negative 5. Our coefficients, I keep saying factors, coefficients are 1, 3, negative 9, and 5. We'll bring down the 1, and we'll multiply, add, multiply, add, multiply, add. So multiply, add, multiply, add, multiply, add. Again, we had a cubic divided by a linear, so that we should have a quadratic. So x squared minus 2x plus 1, and it has no remainder. Okay, so I know in the past we've kind of mentioned that if there's no remainder, then we know that x plus 5 is a factor, okay, of that function, g of x. Okay, so now let's evaluate just the same thing. You probably should expect what you'll get, but let's see what we have. So we'll have negative 5 cubed plus 3 times negative 5 squared minus 9 times negative 5 plus 5. Okay, and again, we could do this on a calculator, or you could do it by hand. I think this is negative 125. Because again, it's a negative 5 times negative 5 times a negative 5 will give us a negative, 3 negatives, right? And then this would be 75, and then plus 45 plus 5. And what do you know? This should end up giving us a 0, okay? Which is the same as what we had before. So we still get the same, it gives us the remainder. But let's talk about the factor theorem. So the factor theorem says that a polynomial f of x, so this is our f of x or our g of x, or it could be any other type of letter, okay, is a factor of x minus a if and only if f of a is equal to 0, okay? So we could go through this whole process with synthetic division or long division, and we ended up finding that that is a factor. But if they're just asking you, is x plus 5 a factor? You do not have to divide the whole thing. You could just plug in the 0, and if it ends up giving us 0, then we know that that is one of our factors, okay? Which should make sense because this ordered pair would be negative 5 comma 0, which is on that x-axis, right? So that would be one of our factors. All right, so let's answer these last two questions. So is x minus 3 a factor of this function? Okay, again, you could do long division or synthetic division, or we could just say, well, the 0 is 3, so we could plug 3 in. Although with synthetic division, I feel like it probably takes you about the same amount of time. It's just so quick, right? And then we're going to use our calculator, and we'd find out that we would end up getting 0. Okay, so that means that there is no remainder, and we'll say no remainder, which means that yes, x minus 3 is a factor. Okay, now let's do one more. So here we have, is x plus 2 a factor of this function? So again, it's 0 would be negative 2. So we'll plug negative 2 in, substitute. Okay, we can just use our calculator, and we would end up getting 6. So there is a remainder. Okay, and if there's a remainder, then we could say that no, x plus 2 is not a factor. Okay, awesome. Well, if you have any other questions, please let me know. I hope that's helpful. We'll see you later.